In the previous video, we introduced Euler's method and the formulas involved in the calculation of Euler's method. In this video, we are going to then take those formulas and apply them to two different examples. In the first example, we're given the IVP dy dx is equal to 6y minus 2 with the initial condition that y of 0 is equal to 2. And we're asked to use Euler's method to estimate y of 1 in 2 steps. Well, recall that we use the n variable for the number of steps, so in this case n is equal to 2. Recall that a is the initial x value, so that's this 0 here that's given as part of the initial condition. Also that b is the final x value that we're trying to approximate. And then the h value, which was the width of each of the subintervals, was calculated by doing b minus a over n. And in our example is 1 minus 0 divided by 2. So our h value is equal to 1/2. So that means each of the subintervals here is equal to 1/2 of a unit. So I like to think of this geometrically as we have the interval from a to b, which is 0 to 1, and we're going to divide it into two parts, and that middle part happens to be 1/2. So the subinterval 0 to 1/2 is the first, and then 1/2 to 1 is the second subinterval. Okay. Great. Now, these values down here, 0, 1/2, and 1, those are the x values that are going to be involved in Euler's method's calculation. So, recall, this is our problem, 2 steps, and h is equal to 1/2. I also want to recall from our previous video the formula that will help us to calculate the next y value. Remember that we take the previous y value, and we add h times the previous slope. So, I like to calculate Euler's method by creating a table, and the table will always have 4 columns to it. The columns will always be labeled n, x, y, and the slope. So n stands for the number of steps, and x and y are the x and y values of each part of each step, and then obviously the slope happens to be the slope at the particular point. So I always fill in the n column first, starting at 0 and ending at the value 2. Because n is equal to 2 in this case. And then I like to fill in those x values that we just calculated from the previous slide, 0, 1/2, and 1. We also know that the y value is equal to 2 because that is part of the initial condition. The remainder of this table is going to be filled out from left to right and top to bottom. So we will first calculate this slope, then we'll jump down here to this y value. Then we'll do this slope, then this y value, this slope, and so forth until we finish up calculating the table. Okay, so the first slope is calculated using the formula 6y minus 2. Well, the y value is 2, and when we substitute that in, we get the value of 10. Then we will use the boxed formula to calculate the next y value. So we take the previous y value, which was 2, and add h times the previous slope. So h is equal to 1/2, the previous slope is 10, and when you perform this calculation, you get the value of 7. So the next y value is 7. We use that to find the next slope. So 6 times 7 minus 2 is 42 minus 2, or 10. And then we again use the boxed formula. We take the previous y value plus h times the previous slope. And 1/2 of 40 is 20. 20 plus 7 is 27. You do not have to calculate this bottom right entry because guess what? We're done. That value of 27, that is the y value on the second step, and that is exactly what we're looking for here. So y of 1 is approximately equal to 27 in our first example. In our second example, we're again given an initial value problem, and we're asked to estimate y of 3 using Euler's method, but in this case, we are given the step size h. We are not given how many steps there are. So think about it. We are starting at the value 2, we are ending at the value 3, and you are going up a quarter unit each time. So if I go 1/4 up, I'm at 2.25. Another quarter up is at 2.5. Another quarter up is at 2.75. And then 4 steps later, we are finally at 3, which means that n is equal to 4 in this example. And yet again, we have the x values that we will need in our table. Excellent. So let's go ahead and create this table. So we have the n, x, y, and slope columns. We will go ahead and fill in the n values already. So 0, 1, 2, 3, 4. We'll go ahead and put in those x values that we calculated from the previous slide. 2, 2 1/4, 2.5, 2 3/4, and 3. And then we're going to throw in the 6, which is that initial the initial y value from our initial condition. And then we're just going to repeat the process of the last problem. We're going to go left to right, top to bottom, all the way down the table. And you don't have to worry about this bottom right entry. So the first calculation will be 2 times y minus 4 times x. And remember, you're using these values, the 2 and the 6, in this calculation. So the first slope is 4. And then we calculate the next y value. Remember, you take the previous y value and add h times the previous slope. So the next y value is 7, and then we repeat the process. So it's like a rinse and repeat thing. You keep doing the same calculations over and over with new values for x and y and the slope. So we get 5, then we repeat the process and get 8.25, and we just keep going. And I would highly encourage you to double check these answers yourself. Make sure you're getting the same values that I am. And again, we don't need to calculate that bottom right entry, which tells us that the approximate value for y of 3 happens to be 12.0625. So I hope these two examples of Euler's method help you. I would highly encourage you to try and make sure you get these values all by yourself. And just like in the previous video, make sure you are looking at spotting patterns like we talked about in direction fields. So notice this is all 2 times something minus 4 times something. That's exactly the same thing we're doing here. And then it's previous y value plus h times previous slope. I hope this video is able to help someone. Good luck on your problems.